Stanford University.
Hi, my name is Edmund. I'm a software engineer at Quora. Prior to working at Quora, I worked on search quality back at Google, and I also helped build out the online video platform, analytics platform at a video company called Uyala. So what I'm going to talk about in the next 10 minutes is how and why we use the cloud at Quora in order to scale up quickly. Can I get a quick show of hands as to how many people are actually familiar with Quora in the audience? Oh, great. OK, so there's a good number of hands. So what we're doing at Quora is basically trying to build a collection of questions and answers that the entire community of users are trying to both create, organize, and edit. The end vision is to build a place where if you want to know something, you can basically find it on the site as long as someone else is willing to share it with you. And so in order to do that, that requires building out an extensive database of knowledge and of people that sort of fill in the gaps of that knowledge. So here's a sample question page that we might find on the site. This question is, so at what point does it make sense for a company to move off of the cloud onto their own data centers? There's a list of topics that are assigned to that question that users have tagged, things like Amazon EC2, cloud computing. And that basically allows the question to go out to people who have indicated interest in those topics, and they'll see this question on their feeds. There's a list of answers that various users have added to the site based on either their own knowledge or their own experiences. Other users can upvote or downvote those answers based on the answer quality, and then we basically take some combination of the author's internal reputation score as well as the scores of all the voters to compute a ranked list of answers on this question page. On the right-hand side, there are a bunch of related questions if you're interested in perusing the topic some more. And at the bottom right, there's a list of question followers who have indicated their interest in the question and essentially subscribe to notifications. So we're a pretty small company, a small team of 30 people. We're based in Palo Alto. Around 20 people in the company know how to code. There's 14 engineers, 4 designers, 2 data analysts. We were founded in mid-2009 by ex-CTO of Facebook, Anna D'Angelo, as well as a prior head of the platform team, Charlie Cheever. We launched invite-only back in early 2010, and then we did a full launch to the public in mid-2010. And so now that we have some background, I'm going to go straight into talking about how we use the cloud, what we use it for, and why it makes sense for us to use it. So our entire product is built on top of Amazon Web Services. We use EC2, we use Elastic Block Storage, we use Hive on top of Elastic MapReduce to do a lot of computation. All the services that we run to power the web application also runs on Amazon. So things like MySQL, Memcache, Search, Home Feed, all of our web servers, the dependency trackers that we use to track and update pages in real time on the site, Scribe for log aggregation, and even development boxes that all of our engineers use are also on Amazon EC2. The data that we log also goes into the cloud. So we log a bunch of fixed schema data, things like clicks and impressions that we just log directly into MySQL. A lot of it is partitioned horizontally by time. There's some loosely structured data. For any news or feature that our engineers build, we basically log that to Scribe. Those get periodically uploaded to S3. We also directly write a lot of blobs directly to S3. So things like images that users upload to answer questions will write to S3, as well as every single HTML response that we've ever rendered to a user will also store to S3. And we use that to maybe debug certain features, or we try to look at user sessions, try to understand what things cause more engagement or less engagement. And so I showed a sample page, and one of the things about Quora, the application, is that it's a pretty rich and interactive experience, and there's a pretty large surface area of features in the product. And that means that we end up trying to compute a lot of things based on our data. So some of the things that we compute include things like trending topics and users on the site that we can feed into recommendations. The homepage and topic feeds that basically show interesting activity on the site as new questions and answers are added. We have to compute those. Every time you add a question, we try to suggest users on the site who have answered similar topics in the past and who might be good candidates to answer the question you just added. We have to compute those on the fly. And there's also a set of other queries and other computations that we have to do in a more periodic fashion. So for instance, we maintain this notion of a people rank reputation score, kind of similar to Google's PageRank, but instead of basing it on web links, we base it on follow relationships or upvote and downvote relationships between users, questions, and answers. There's standard things like internal dashboards and metrics, like actives, daily signups that we compute. We also run a lot of classifiers over our data. We try to detect fake names because real identities is an important part of the site, as well as classifying particular answers as being good or bad answers and using that information to adjust distribution of that answer on the site. And so for many of these sort of known and structured metrics, it actually works really well for us to run those queries directly either against MySQL or use a aggressive memcache tier in front. And that works well because a lot of the data that we run sort of these analyses over are already cached in order to allow the site to run quickly. And so those pieces of data tend to already be in cache. It also makes it really easy for us to then leverage application level logic and code to run the analysis that we need to do, to sort of answer questions about things that require knowing the order of answers on the page, that require a lot of application level logic. But at the same time, there are also a bunch of other queries that we need to compute that are more ad hoc. Things like some of the questions that our data analysts have asked in the past few weeks include things like sort of how often have users clicked on the help link in the footer of our pages, or sort of what percentage of users stuck around the site after clicking an answer in their home feed for more than 3 minutes, or sort of what is the average time spent on a page depending on sort of different landing pages. And so for these, our data analysts basically use a lot of Hive queries. They'll run some over persistent AWS clusters that we have set up for the sole purpose of running Hive. And if there are larger queries that they need to run, they would typically just spin up additional clusters as necessary to run those queries. So why does it make sense for us to use the cloud? The main reason is because we're trying to optimize for product iteration and development speed. It's really quick and really easy for us to basically spin up new machines as necessary. If we wanted to experiment with a completely new web tier, we basically spin up a bunch of machines and throw live traffic at it. It works. If we wanted to run cohort analysis to see and bucket all users based on the week that they signed up and sort of see long-term engagement trends, it's really easy for us to spin up a new cluster, run a bunch of Hive queries, get that analysis, and then take that cluster down. Or if we wanted to compute weekly digest emails, we can easily spin up a cluster and then figure out the top, say 5 answers on the site, personalized to you based on the topics that you follow, send out a bunch of emails to all the users on the site, and then take that cluster down. Or if we are experiencing large traffic spikes because we're getting a lot of press, maybe in TechCrunch or we're in the front page of Reddit, we can easily spin up new machines to accommodate that load. It also gives us this additional flexibility where we can basically trade off engineering time that we could spend trying to optimize a given service, and instead basically upgrade to faster or larger or more boxes. And so ultimately, what this allows us to do is focus a lot more energy, a lot more effort onto growth and engagement, which is for many startups is how which will drive more value at the company. And using services like AWS allows us to amortize a lot of the cost of our servers over time, even though in the long term it ends up being much more expensive than if we had bought our own machines. And so I've left some additional follow-up links that some of the people in the audience might be interested in sort of learning more about after this talk. Things like sort of why we chose to use MySQL instead of some of the NoSQL solutions out there. There was sort of some speculation after a major AWS outage back in April whether that would sort of impact the future of the cloud, and our CEO sort of wrote a pretty good answer about why, even though Amazon went down, it's still pretty much the sort of best cloud solution out there for startups and for people who have large amounts of data. It's probably more reliable than sort of building your own ops team and trying to build your own reliability in your own data centers. And if you want to learn more about Quora or about database systems, sort of left a link on sort of the topic page for Quora database systems on the slide. So I definitely encourage you to check out Quora if you haven't checked it out before. But thanks.
For more, please visit us at stanford.edu.